So this demo is about motion in 2 dimensions, and we will show like how vertical motion and horizontal motion are related. And this is the principle behind projectile motion, which you have already seen in the lectures. And first, let me try the stationary case. The object does not have any horizontal motion. So this is called a ballistic cart. So what happens is that when I press the remote, it ejects a ball into the air. And the ball, when it's in the air, it's under the influence of gravitational force. So it just displays the vertical motion due to gravity with the constant acceleration. The acceleration is minus g. G close to the Earth's surface is 9.8 meter per second square, as you know. And let me try that case first. When the object is stationary and the ball just moves vertically upward and lands directly into the cart. So you know about this motion. You have used the equations of motion with constant acceleration in your problems, and you are very familiar with this case. Now let me try a slightly different case. Now I will put some horizontal motion also into the cart and the ball. So I will push the cart and the ball at the same time. So when I push them, I apply some force, and force is equal to mass times acceleration. So I put some acceleration initially into the cart, but once I let go of the acceleration is again 0, because I am no longer imparting a force onto the system. Then it's traveled in the horizontal direction with a 0 acceleration, ax equal to 0. But as the ball is ejected, its vertical motion will again be due to the force, the acceleration due to gravity as before. And let's see what happens in that case. See, the ball is still landed on the cart, even though the cart was moving, and that's because both had a 0 acceleration in the horizontal direction, and the cart had a vertical acceleration, but the horizontal and the vertical motion are independent in this case, as in projectile motions, as you have seen. Now let me do a different case. Now I will first eject the ball into the air and then apply the force on the cart. So that means the acceleration of the ball and the cart, the horizontal acceleration, will no longer be the same. And let me still see if the ball still lands in the cart. Now the ball actually does not, and I was almost breaking the device, but you still get my point. Now the ball dropped in a different position, and the cart moved along, because they were the cart was under an applied force after the ball was released in the air. So its horizontal motion was different. Its horizontal acceleration was non-zero in that instant. So this demonstrates how vertical and horizontal motions are related.